Welcome to the second lecture in this series about geographic information systems. Today we will have a brief look at data formats, vector and raster data, and data quality. Learning goals are to learn about vector raster data, understanding topology, and how to assess data quality. First of all, we have two main types of data. There are a few more, but the two main types are raster data, which consists of raster cells. You could imagine like an old TV where you can see each LED cell. And vector data, which consists of points, lines, and polygons. Both data types have individual advantages and disadvantages. Some analyses are only available in raster, others only available in vector, some are available in both. In general, vector data is a bit more versatile and it's easier to lay out, so we often try to transform our data into vector data at the end of a geoprocessing process. If we work with vector data, then topology is an important concept. Topology is about four basic spatial relationships: adjacency, connectivity, containment, and coincidence. In other words, it's about neighborhood axioms or neighborhood formula, how to describe the neighborhood of a vector data object. This will become a bit more clear if we look at some examples. We can compare how points are located to each other. We could have a small point within a big point. We could have a point on a line or next, right or left to a line. We could have a point inside a polygon, outside a polygon, or on the boundary of a polygon. We can also compare lines to polygons. Polygons are made from lines. These lines are then called the edge of the polygon. Or we have different polygons adjacent to each other. And if we map an area, for example, for land use or land cover, we try to only have adjacent polygons with no gaps in between. Therefore, we talk about topology error if we have a mapping error and end up with a small gap or an overlap. If these overlaps are very small, we also talk about slivers. You see that on the right. And there are topological tools in most GIS programs to help you mapping an area without any gaps or overlaps, slivers. These are called topological tools. So topology is a first measure of quality that we have to look at, especially for vector data. Other quality measures that apply to all types of data are completeness. Are there gaps in our data? Precision, how precise was the process, and accuracy. There is a difference between precision and accuracy. It would be beyond this to go into detail, but maybe look up the difference as a homework. Consistency, is the data consistent, and how up to date is it? If we have species sightings that are 20 years old, then those species might not even live in this area anymore. So how up to date is their data? And the main problem in GIS is, if your data is rubbish, then you will get a rubbish result, to put it informally. But it does sum up one of the main problems of many data projects. It's all about the data. You can easily master GIS with some exercise, but getting the right data, having data in suitable quality, that's often the biggest challenge. So how do we improve our data quality? Here are some advice from Ravi or from Esri India, which I changed a little bit, adopted it to this lecture. First of all, get a good idea of what your end users need. Maybe make a use case. Then choose only relevant data from legitimate source. Not something you found somewhere on the internet, but it should be at least well reputed citizen science side. You can of course work with citizen science data. There are very good examples like OpenStreetMap, but that's data that has been validated in a peer review process. Test the data quality in each phase of your data capturing process, and if possible use automated software tools. Sometimes it's easier to, or quicker to just do a few steps manually, but if you use manual techniques too much, then you increase your prunability or your risk of making errors. Afterwards, check your map elements. Does it have a scale, the right scale? Please always say what sources you used, and is the map oriented towards north or is it oriented somehow differently? And track your data origins, the changes you apply to the data, etc. Track that in metadata sheets. I know it's sometimes a bit of a hassle to write down metadata, but it's very important for the users of the data, and you should always use and update these metadata sheets. Usually they are saved as a text file together with the geodata. So if you stick to this advice, then I'm sure you will get some good results. See you for the next lesson.